Good morning all. Power tools, an electric drill and 2 batteries. Now this is the Ferrex brand range. Ferrex. Being sold at Aldi at the moment. The drill is £20. This small battery is 15 and this big battery is £30. What's the most interesting thing about this range of power tools? This battery. Now, Ferrex, is that a good power tool brand name? It's a bit like ferret. Well, ferrets are fast, so that's quite good. It's also a bit like ferrous, made of iron. That makes it sound strong. So fast and strong. I think that is actually quite a good brand name. So why is this battery really interesting and this one, not so much? Well, it's because this one is dual voltage. It's either 20 volts or it's 40 volts. Now that's pretty intriguing. And therefore it's either 5 amp hours or it's 2.5 amp hours. Interestingly, this one, 20 volts, is only 2 amp hours. So I got a feeling, and I think I've seen some pictures of this, the cell type in here is different. It's higher capacity than the cell type in here. So yeah, this is the interesting battery because it's dual voltage. So since I bought this battery, my mind has been absolutely buzzing. How does this dual voltage thing work? What's inside here? It's clearly going to be 5 cells for 20 volts. It's the same as the 18 volt batteries. This is just 20 volts because they've kind of measured it at 4 volts per cell when they're a little bit more fully charged. So 5 cells, but then there's a second row of 5 cells in order to give you the 10 cells you need for 40 volts. So how are these wired? Are they pre-wired kind of in series? I don't think that would work because the 20 volt power tools need to use this as a 20 volt 5 amp hour battery. So they must be entirely separate and they can be wired in series or they can be wired in parallel. Now, how is that wiring change actually implemented? It's fascinating stuff. Well, here are some clues. This one says max 20 volts, but then curiously, so does this one, max 20 volts. This one says variable power, which is a bit bizarre. All batteries are variable power. Depends how much power you want to draw. But this one says 2 amp hours, 36 watt hours. Now this one says 2.5 amp hours, 2 times units. So maybe they're acknowledging that there are 2 entirely separate 20 volt, 2.5 amp hour batteries in here. Battery meaning a group of cells. 90 watt hours, that's obviously the 2 combined. Curiouser and curiouser. So we're going to have to open this up to dig a little deeper into this mystery stuff and the battery. Now, how many contacts are there? Well, there are 5. Now we'll look at the markings on those contacts in just a minute, but there's also a little fuel gauge here and it's showing 2 rather disappointing yellow LEDs. I mean, they could at least have been blue. So this is at its storage charge level. But what's that telling you? Is that the storage level of the first battery? Or is it the storage level of the second battery? Or is it the storage level of both batteries in parallel or both batteries in series? How's that wired? How can that be measuring the storage charge level of both of the rows of cells? Intriguing. Let's look at these markings. Now, well, here's a clue. B1 minus, B2 minus, B1 plus, B2 plus. So it looks like first and fourth are the first battery, 20 volt battery. Second and fifth are the second 20 volt battery. So I should be able to measure 40 volts, but I may only be able to do that if I actually link B2 minus to B1 plus. Do I dare shove a piece of wire in there? Now this says T, but it also says ID. So T for temperature, presumably, so that this thing can tell the charger, I'm too hot or I'm too cold, don't charge me. But what's ID? Is there data on there? Interesting. Let's look at the other battery. Because this battery being just one row of 5 cells is 20 volts, it's not going to have a B2, B1 thing, is it? So I imagine there'll be the same number of ports here, but yes, you can see that actually only 3 of them have metalwork in them. This one also has a fuel gauge. Oh, disappointing yellow again. And it's also at storage charge. And yes, you can see that curiously B2 has contacts, B2 minus, B2 plus, and T of course, and ID is also there. So what does ID do? Is it clever enough to tell the tool what type of battery it's got put into it? So both batteries at storage charge. What are we expecting? About 18 volts, something like that. Let's check this one out first. Oh, 17.95 or thereabouts. Let's check out B1 on this one, B1 plus. That is also, that's a little bit lower, just under 18 volts. What about the other one? Is it going to be totally different? No, it's surprisingly similar. 17.65 and 17.65. How are they so precisely the same? That's interesting. So here's the conundrum. If I connect this 20 volt battery to the 20 volt power tool, and I've got the drill driver, it's going to just use these two connection points, see 20 volts, power the drill, everything's fine. But what happens if we connect this battery? If it thinks that this battery is a 20 volt battery, it's only going to use B2, isn't it? It's not going to use B1. So what does it do? Does it use B2 and then when it's flat, it switches over to B1? Or does it somehow put B2 and B1 in parallel, which would give it more grunt because you've got a lower impedance? Or does the ID send some sort of data, or is it a primitive ID? Is it a voltage level or a high and a low? It's just intriguing. Actually, I suppose I could measure the voltage on that ID pin, couldn't I? Incidentally, if you came to this video thinking this was just a tool review, oh no, this is a geek fest for this power tool battery range. Okay, ID. How many volts? Not many, but there seems to be some sort of capacitance type thing going on there. Let's check the ID on this one. Yeah, a bit of capacitance there. What about B2 and ID? Well, the ID connections are really thin, obviously, because not much current's going to flow through there. That looks like it's open circuit, because that's drifting. That's on millivolts. So yeah, those two don't seem to have any connection with each other at all. What about B2 plus and ID? Minus 14 volts. Minus 14 volts? How's it getting that? Okay, so ID to B2 plus is sort of around 15 volts on the big battery. Oh, that's stuck. ID to B2 plus, is 18 volts, in other words, the full voltage of the battery, on the little battery. So is ID a voltage level type thing? Or am I being misled here because ID also doubles up as the temperature indicator? I mean, these two batteries should be at the same temperature, 15 volts on that one, 18 volts on that one. Interesting. I think we're going to have to take a look inside the power tool itself. So here it is, the Ferrex drill driver, chuck, yeah, torque thing, gearbox. But I'm most interested in what's in here. There are 5 connection points. Now in most power tools, there are only 2 because it just picks off the voltage, the current. It just picks off the power straight off the battery. It doesn't have all this ID and multiple connections business. So this hints at something really quite different. Okay, quick test. Small battery. Sounds like that. Big battery. Didn't sound much different, did it? I was thinking the big battery might make this thing go ever so slightly faster. I mean, yes, it's using it as a 20 volt battery, but I presume it's putting the 2 packs in parallel. Maybe it isn't. Maybe it uses one set of 5 cells first and then switches to the other set. Intriguing. One thing's for sure, this is not brushless. Look. Lots of sparks in there. So this is a brushed tool. So here on the drill it says Konmetalmeister GmbH and it says Germany. Now there's no mention of China there. The batteries say Varovic Van Rompuy NV, Belgium, made in China. Both the batteries say the same. Now wait just a moment. This contact T and ID actually seems to be two contacts. There's a top contact, and it's quite hard to see because I can't get the lighting very good. Then there's actually a bar of plastic, and then under that there's a second contact. I think this is going to have to come apart, but I've just noticed that this has got some fairly deeply embedded security Torx with a little pip in the middle, and it's quite a long way down. So have I got something that's going to be able to open this? So now that I've discovered there's an extra contact for the ID, let's measure it with respect to B2+, and on the little battery it's 16 volts. So B2+ is 16 volts above ID. On the bigger battery, let's go B2+, that sits in there if I'm careful. ID is the underside one, 5 volts. So B2+ is 5 volts above ID. B1+ is 7.5 volts above ID. So that's perhaps it. Maybe it's the voltage of ID with respect to B2+ and B1+. Don't know how the tool makes any sense of that though. Well, now here's the thing. I've got Torx, and I've even got security Torx. This is a security T10 with the little hole in the end. But I don't have long reach security T10 Torx. So I can't at the moment get the 40 volt battery apart. So I can't work out the precise nature of what's connected to that ID pin. It's underneath. And also can't work out how this can measure the level of both batteries, in a sense, if this is two batteries in one package. It probably doesn't. It probably only measures the level of one, but they're both kept approximately the same, which they would be if this was in series as a 40 volt battery and in parallel as a 20 volt battery. That's my guess, but that's going to have to wait. However, I can take apart this battery. I don't think we'll see a lot. We may see what's connected to the ID pin, and I can also take apart the drill, because it seems to me that what this drill probably does is, given an appropriate ID, and actually we can see that that is an offset pin, so this is not measuring the temperature. It's going to be the charger that's more interested in the temperature, this top pin. This is measuring the bottom pin, the ID pin. This maybe just goes to a MOSFET which turns on the contacts for the other battery in the double battery. Maybe that's how it works. It might be quite simple like that, but I should be able to take this apart because I think all the screws are accessible. So let's start with the 20 volt battery, the single set of 5 cells. I can get to these screws. Let's get them all undone. So this has already started springing apart, but the little label there is stuck across the battery, so I'm going to have to lift this little cover for the battery voltage or battery capacity, state of charge I suppose, indicator. It's probably a voltmeter of some sort. Right, here we are inside the 20 volt battery. Now let's take a look at what these cells are. And they are LG AAHD2 1865. So they're 18650s. I'm not sure what the AAHD2 ident is, but I guess I could look that up. Here's the battery level indicator. And yeah, it looks just like a voltage monitor. And very interestingly, did you notice earlier on that the second LED looked dimmer than the first LED? This looks very, very simple. There's nothing on the back of that board. And it looks to me like it's just voltage of the entire pack. Oh no, maybe it's just voltage of one cell. Well, I don't know. And there are a couple of diodes. So maybe it's just using diode voltage drops and 3 LEDs with resistors, because that second LED is definitely dimmer than the first one. So maybe they just go off because the voltage across them just drops below their forward voltage threshold. I mean, certainly this is very, very simple. Now, I'm not sure what I'm going to be able to see on the underside of this BMS board. I don't think I'll be able to see much because it doesn't look like it's going to lift very far, because it's held in with all 6 of these quite significant bits of metal tabbery. Yeah, that doesn't seem to come off much. I can see some ICs under there. And in fact, trying to lift this up is not a good idea because there's a component across these 2 pins here. Let me see if I can illuminate that. And it's kind of siliconed in between the battery cells. So that's clearly the thermistor or temperature sensor. And you can see that it's connected between B- and this track, which almost certainly runs down to the T connector. There's, I can't get any light on it. There's a T stroke ID there. So this is presumably going to the T connector. Are there 2 connectors here? Yeah, we've got the T connector on top and the ID connector underneath. So unless I want to disturb the positioning of that thermistor, which I don't really, I'm not going to be able to take a look under there. In any case, I think there's probably more to see in the body of the drill itself. I'm not sure I like this terribly. You've got a screw there with a very obvious cutout in whatever that terminal is. It's one of the cells, because that screw is potentially, this is coated, but it's potentially connected to B-. So you don't want this terminal here touching that screw. But this one, there's a sort of semi cut out there, but it's not big enough to cut the head out completely. The head lands on here, on the temperature sensor connection and B-. And I don't know whether I'm dreaming, but this screw feels slightly warm. I'm probably dreaming that, but I don't like the fact that that screw bridges right across that lot. I think I might put a washer in there. In fact, the thread is stripped out of that pillar, so I think I'm just going to leave that screw out. Aha, on this voltage or state of charge indicator, the 2 diodes on there are marked WK and WJ. So maybe those are Zeners. Perhaps that's how this thing's working. Maybe those are Zener diodes. But then isn't that going to consume... maybe they don't actually come into play unless you press the switch. Yes, it looks to me like the switch actually is in line with the positive. But I think those are probably Zener diodes. And that's what's doing essentially the voltage measuring for the entire pack, would be my guess now. So switching my attention now to the drill, it looks like the gearbox assembly and torque clutch assembly comes off with 4 screws. Now these are standard Torx, they're not security, so I'm going to go and get a long reach standard Torx bit. And here we are inside. So motor, gearbox, that's quite an interesting gearbox switch. It just comes down to this sort of levered piece of wire, quite like that. There's the speed controller stroke switch, little ferrite there that both the positive and the negative are on. But the interesting bit is down here. And yes, we have a couple of MOSFETs attached to the battery connections B1- and B2-. And that makes perfect sense. If the source of the MOSFET is on the negative, then yes, the gate will be positive with respect to the source, and that will turn the MOSFET on. Let's take a closer look at that. Well, now that's interesting, because this offset pin in the middle there, if you slide the battery in, it's actually going to connect to the T pin, not the ID pin. So it is correct on this board where it says T for this center pin. So is the drill interested in the temperature of the battery? I suppose it is. If the battery is extremely hot, maybe the tool shuts down and stops operating, but it looks like the tool is not particularly interested in the ID pin. So probably the charger is looking at the ID pin. The tool is only interested in the temperature pin. What it does look like is on the battery positive connections, this is B1 positive, B2 positive, there are a couple of little SOT23 devices, so maybe they're just checking whether those voltages exist. This is perhaps a microcontroller. I don't know. I'll have a look at the number of that in a moment. And then it's deciding whether to use B1 or B2 by switching these two MOSFETs on. Is it going to switch them both on and put the two batteries in parallel? It looks to me like this copper area for B1 and 2 positive is actually just one copper area. I'll try and get in closer on that. Yes, it does look like that's one copper area, but then it looks also like B1 minus and B2 minus is one copper area. So it looks to me like when you plug this tool into the battery, it just simply puts the two battery packs in parallel. Doesn't look like there's any intelligence there at all. It just dumps them in parallel. So I imagine the 40-volt tools will just wire them in series. It's actually quite crude. The two MOSFETs are just in parallel, so it's just for doubling up the current, it looks like. So what on earth is that chip doing? Is it doing anything clever? What is it? L518P22A. No, LG T8P22A. Is that an LG chip? Well, I think the only reference I can find to this chip is in a power bank. And I think probably in this application it's being used to turn these MOSFETs off. Now the only reason I can see for turning off the supply, the negative supply, these are now in parallel and these are in parallel, I think would be to protect the battery. So perhaps the battery has a BMS in it, but it doesn't have an over discharge protection, and so probably what all this lot's doing, it seems a lot of circuitry in here, but it's just providing over discharge protection for the battery. So on the larger battery, the two packs are simply put in parallel the instant you plug the battery into this connector block. Where is it? It's under here. Oh, what we've got under there? Nothing. And then this chip and the MOSFETs and these detectors are simply measuring battery voltage and acting as a over discharge protection. The tool will just shut off when the battery gets too low. I think that's all this does, but it does look very complicated. So I think that really answers the mystery. How are the two battery packs in here used? Well, the tool simply wires them in parallel, like this one, because it's a 20-volt tool, or it'll wire them in series, the 40-volt tools like the angle grinder, the lawnmower, which has had mixed reviews, would wire them in series to get the 40 volts. It looks like inside the battery packs themselves there are BMSs. Maybe this is just simply two battery packs stacked on top of each other. Perhaps there are two BMSs in here, and maybe the charger is actually a dual charger and it just charges the two halves of the battery pack separately as though it were two chargers. And then this board here just looks like it's a low voltage disconnect. So is that the end of the mystery? I think it probably is. So cheerio.